disadvantages of fine-tuning a model, right? So let's say if you have your company policies, right, that has pricing policies, HR policies, leave policies, or certain FAQs, right? So what we were telling is we will fine tune the model so that the model can answer those questions as well, right? But tell me one thing, like what happens if your HR policies or like company policies keep on changing very frequently, right? Will you go in again and again and train the model again and again? Won't that be very time consuming process or very difficult process? Because every time something changes in your data, you go in and you have to train the model again on it, right? It's like seems like a very tedious task, right? And very difficult, because also we saw that we took a very small example of how the training can happen, but in actual production you will have a lot of tons of data, right? So it's not very easy to go in and click a few buttons and the training will be complete, right? We saw that training takes a lot of time, a lot of compute. So it's not easy to train the model, right? And if your company policies or the documents are changing very frequently, it's not a good idea. I mean, then fine tuning becomes a disadvantage. So you can't go in and fine tune the model. You have to, so what are the disadvantages? You have to re-fine tune the model with the updated data all the time. What does it mean? It means that you are recurating the data set, retraining the model, reevaluating, and redeploying, right? So that is a tedious process, like I said. Until you retrain, the model will then confidently gives you outdated answers. So now if your HR policies or finance policies or anything of your company data is changing, right? And if you have not updated it to, if you have not trained the model on the latest data, the model will answer, but it will confidently give wrong answers every time because it does not know the updated information. So that is these are the disadvantages of fine tuning. So how do we solve this problem so that we don't have to train the model again and again? So that is the place where like this retrieval augmented generation comes in. So you might have heard of RAG a lot. Like RAG is one of the trending words nowadays. Every company uses it in its AI project. So RAG stands for Retrieval Augmented Generation, right? What does RAG do? RAG lets an AI look up relevant information before answering instead of only relying on what it already knows. Okay. So what does RAG means is like we will develop a mechanism wherein it can look up some data and then based on data, it can answer that question. Okay. So that is what RAG will solve for so that you don't have to fine tune the model. The model has learned how to answer in English. It has now some trained, it has now some information on how to answer in the form of Q&A. That's enough. If my data is getting updated every day or like in every month, right? I don't want to go and fine tune my model every day. So then researchers came up with this technique, which is called RAG, wherein now the model is fixed. We will not update the model. We will do some engineering around the model so that model can pick up the latest data and answer user queries based on that. Okay. So that is the main idea behind RAG. Okay. So why is RAG needed? I'll repeat one more time. AI models have limits, right? They do not automatically know your private data. So we saw this in fine tuning also. So that like, let's say if your company has some specific data related to your company, they will not, they are generally when you access your company systems, right? You have to log in into VPN and stuff, right? Without that, you cannot access like, let's say the Confluence or Jira or any other systems in your system, in your company. So obviously when OpenAI is training its model, right, it will not train it on your company data because your company has restricted access to that data, right? So, but I am building a chatbot wherein I want the chatbot to answer not just based on internet, but on my company specific data as well. So what I will do is I will use the RAG technique. Okay. So fine tuning a model and RAG, both of them solve one similar problem, which is like if I have my company specific data, how do I train the model so that it can answer that data, right? So RAG solves one of these problems, that if your company has some private data and you want, if you have built a chat application where you want it to answer based on your internal docs, support tickets, product manuals, database content, right? Then it can answer that, right? Right now, the model will not be able to answer with generic data, right? Now, let me take one more example. Let's say we all have support teams in our company, right? So the support, let's say your company has 10 products, right? So those product information may be present on the internet, but there might be limited information on the internet. The engineering blogs, how the internal systems were built, and all those things is internal to the company, right? So when you ask GPT about a question which is related to your internal frameworks, it will not be able to answer. But I want to create a bot so that the support persons, when the bot answers, it can look up my internal documentations and answer that, right? Wouldn't that be helpful, right? So that is where this RAG comes in. Also, there is one more use case why RAG is needed is models have a knowledge cutoff date, right? So what it means is AI models are trained on data up to a certain time, right? Anything created or updated after that, the model is unknown to that, right? So when we train the model, right, we saw that we need certain data sets, right? The data sets are not like that it keeps on updating every day something new is happening, right? So we can't keep on training the model with the updated data set. So the models have a knowledge cutoff date. Like if you go in today and check, every provider will let you know in its documentation that the knowledge cutoff date for GPT 5.5 is, like, let's say 10th Feb. After 10th Feb, whatever happens, the model does not know about it, or the model is not trained on it. This is also a problem. I want the model to answer based on latest trending information, right? Whatever is trending. So how can we do that? RAG is the answer. For example, if a new iPhone model was released after the AI model's training cutoff date, the model may not know its feature, price, or reviews. So let's say your the model was trained till only December 2025 or say. Now a new iPhone comes in February 2026. So if you go in and ask GPT that tell me the features of iPhone 17, so it will not be able to answer that because its training data does not have that at all, right? So how do we solve that problem? We'll see how RAG will solve that problem. Okay. And like I already said, training a model again and again is expensive. So whenever new data is coming in, I cannot go in and train the model again and again. So because of these reasons, RAG came into picture. Okay. What are the primary three reasons? Uh, Private data is not known to the models. That is one use case. Models have a knowledge cutoff date. That is the another use case. And retraining the model is not possible every time. So that is why, because of these limitations, we need to have a some architecture or some format wherein we can take the latest information or private information. Okay. So now, just I think I have already explained this, but just reiterating. Imagine, so that the concept like sinks in completely. Imagine you ask a company, you ask a bot, what is your company's refund policy? Company data is private, right? We know that model is not trained on it. AI answers from general knowledge. It will just give you a general answer, which will not be correct, which means the model will hallucinate, right? With RAG, the system, what it does, the system, how the system now will behave is, first it will go and search for company document for refund policy, right? Then it will in the particular document it will find the relevant paragraph. Then the paragraph will be provided to the AI. The AI will then generate a human readable or easy to understand answer based on the document. So this is how RAG workflow will work. Okay. The model will search some documentation from a vector database, and then it will extract some relevant information or the latest information, and then it will answer you. Let's deep dive into like how it works end to end. Okay. Okay. So the workflow will be something like this. User asks a question, system searches the document or the database, relevant information is retrieved, AI reads the information, and then AI generates an answer. Okay. Keep this in mind while I explain the RAG workflow. Okay. So you have a chatbot, the user will first ask a question. So instead of answering directly, right, what the system will do is it will search for documents in a database or a document store somewhere. It will fetch the information from there. Then it will format the information, and then it will answer based on that. Okay. This is in simple, like I said, customer support agent example, which I have just given over here so that while you are reading, it makes more sense for you guys. Okay. Now let's look at the overall architecture of how RAG works end to end, right? Like I said, like let's say if you are a customer support agent, right? Then you have your company docs, right? Your knowledge base or the knowledge of your products is there in some company PDF or like some company database and everything. So now what do we actually do in RAG, right? So we will take all those documents, like think of them as HR policies or some information coming from certain database, or if you have certain PDF documents, we will take all those documents, like whatever is your restricted knowledge base, we will take all those documents, and what we will do is first we will chunk them. Okay. Chunking, what it means is breaking down the document into smaller pieces, right? So why do we need chunking is basically the model has a limitation, right? It can read up to only certain characters. Like we talked about the context window, right? 2000 characters only. So I cannot take a 100 MB document and put directly pass it to the model, right? I need to break it down. So that is why I chunk the I break the documents into smaller sentences or paragraph by paragraph, that is small chunks, and then that is called text chunking. We took the document, break the document into smaller pieces, okay? Smaller pieces like this. Now, what we do is we embed those documents. What is, or we do vector embeddings. What is vector embeddings? We have gone through that in like a lot of details, right? Vector embedding is nothing but converting the smaller parts of the document into the vector format. We saw, right? We take words and convert them into vectors, which represent that numerical, which represent their numerical meaning, right? We saw this. How do we take a word and convert it into a vector, right? So here also, this is why I told you at that particular point of time why this is important. This vectorization, what is happening over here? Because see, here in RAG also same thing is happening. You have your company documents. You are breaking them into smaller pieces, and then you are doing vector. You are converting them basically into vectors. And now what you do is you store, after you have converted them into vectors, you store them into a vector database. Okay. So this is the indexing layer. Now, just to reiterate once more, what are we doing? What is the end-to-end process, right? Our problem was our company specific data was not known to the model. I am building a chatbot for the company where I want I am using LLMs or any of the GPT models, and I want that model to answer company specific questions also, right? Model is not trained on company specific data. So what I am doing via RAG is I am coming with a process. I'm coming up with a architecture or a process wherein the model will be able to answer based on company data. So for that, the first step is I take all the company documents, I chunk them into smaller pieces. This is just breaking down, convert them into vectors. We have already seen how vectors are converted. We'll see it again just in a moment. And I store it in a vector database. Okay. Now what happens? Now let's say if I have built a chat application. Okay. Now if a user uses this chat application and asks a question which is company specific. So LLM, what it will do is it will say, hey, I don't know the answer, but can I look up this information or not? Okay. So what it will do is it will convert the user query or like the user query, whatever the user gave, and convert this user query also into a vector embedding, okay, which is like this number 0.7, 0.9, something like that. The whole user query it will take and convert it into a vector, and then it will look up the vector database. Hey, do I have any similar? So I have a user query. Do I have any documents in the vector database which have a similar intent or which answers this particular question? So it will try to find that. It will do a similarity search or a semantic search in the vector database. It will find top 10 documents like, hey, these top chunks have this similar answer, right? So in vector database, what were we storing? Chunks of data vectorized. So while retrieving the data, also what I will get is top 10 chunks or top 10 articles, whatever it is. Now I will pass this to the LLM, okay, after searching the vector database, and tell the LLM, hey, this is what I found out after searching the vector database. These are some similar documents. Now LLM is already trained to answer, right? So what it will do is it will see, hey, among these documents, what is the most relevant answer? It will format the answer in the form of a Q answer, or like user asked a question, right? So it will format the answer as from this. It will find the answer from these top 10 documents which were found after the similarity search, and then give the response to the user. Okay. So this is what a RAG workflow looks like. We'll dive deep into each of these components, but on a high level, is it clear? And these two flows which I talked about, right? They don't happen in the same workflow when the user is typing in a query. So when you are building your chat application, right, then itself you have to first index the data. So when you build the application, right, first you have to index the data. You have to figure out your company docs. You have to break them down. You have to convert them into embeddings, and you store it in the vector database. Now you build the chat application. You via APIs, you know how to talk to the vector database. Now, when the user query passes in, the model figures out, hey, I don't know answer to this question because I'm not trained on the data. It will call the vector DB via an API. The API will give you back the results now, which are top 10 articles. Now the LLM will just format those answers, or since we have fetched top 10 articles, right, it will find out which one is the most relevant to it. It will format accordingly, and it will give the answer back to the user. Is this workflow clear enough? Yeah. Or are there any questions around this? Because we will build on top of this, but is it clear? Is it making sense how a RAG pipeline works? What is the indexing layer and what is the inference layer?
Yeah, I'm okay.
Yeah, like I said, when I started, right now, all of this is not very difficult to understand. We are, like told you, right? See here, LLM is now we are using the model and building the engineering around it, right? It's not very complex. It's something which we do in our day-to-day life as well. Like whenever we are building an application, we have databases, right? So if I want to query like all the like if I have an e-commerce application, right? What do? I can search for products. I can give the price of the product and all those things, right? What do? We call databases and retrieve that information, basic CRUD. In order to serve any application does CRUD on the databases, pulls data and give you the answer. So here also we are doing mostly the same thing. The only thing is like how are we leveraging LLMs to improve our applications, right? So that is how RAG comes into picture. So this use case is pretty clear, right? What are we doing and what are the different components? Now we will deep dive into like what of these component means, right? But this should be very clear in your mind that what is a RAG? Nothing, but we are storing our company specific data into vector DB. Why vector DB? Because because we have certain documents, we are converting them into smaller text. Why? So one question which can come in your mind is, hey, why do we need this vector DB? Why cannot I store the information in Elasticsearch or any search engine, and why can't we get that information from there itself, right? Why do we actually need vector DB? The advantage of using vector DB is like traditional search applications, they do text-based searching, which is keyword matching. Okay. They don't do semantic matching, right? For example, like when I type in a query, like like let's say an example is like what is the leave policy in my company, right? So if I use traditional search based approach, when the user rephrases his query into like hey, what how many leaves do I have, or rephrases his initial query into some other English words, right? So the search will fail because you are doing a text match over there. Okay, text matching we are doing in our traditional applications. In RAG, what the advantage we get is, why we use the concepts of vector DB and vector embeddings and all this stuff is we can do semantic search. Semantic search means is it looks at the words and understands its semantic meaning rather than doing a keyword search. Okay, it understands your intent. If you even rephrase your question, it can understand the intent is this only. It's not like keyword match. Okay, so that is why we use this vector DB and all that stuff, right? So we saw the indexing layer, and we also saw how retrieval, like when a user query is passed in, how does LLM searches that answer and then answers back. Okay, so what are the components of the RAG? We saw all these are the components of the RAG. Now let's go into each of one of them in detail, right? So first and the main component of the RAG is external knowledge source. So whenever you have to develop a RAG application, first you have to see what is my knowledge source. So if I'm building a chatbot application which can answer based on my company's HR policies, leave policies, right? Or certain like financial policies and all those things, then first I need to figure out where does this data live? Is it in the form of PDF? Is it stored somewhere in SharePoint or some database? So that is called the external knowledge source, right? Stores domain specific or general information like documents. The information could come from anywhere, right? So these documents can be stored anywhere in a database. Maybe you can retrieve that through a API call, through a cache. They might be stored in Redis or any file system, right? So you have so external knowledge sources are this component, the database or the documents where your company specific data lives. Okay. Now we come into this part, which is text chunking and pre-processing. I have all of this data, but in order to store this data and do semantic searching, I need to convert them into vectors and store them into vectors. So what we will do is we have to break down that bigger document of 100 MB into smaller documents or something like that, so that we can store the context. Okay. So what does text chunking and pre-processing, which is this step, what does this step do? Is breaks large text into smaller, manageable chunks and cleans it for consistency. LLMs and embedding models have token limits. Why do we need to do it? Why do we need to break this 100 MB document? Is we already saw LLMs have and embedding models have token limits, right? So I cannot go in and write an essay in the ChatGPT prompt because the model has a limit. It can only process certain characters at a time, certain tokens at a time. So that is why I'm breaking down also the documents into smaller tokens, because I want to embed it, right? The model cannot understand it like big documents, right? So I'm breaking down them into a small parts also. They can only process a fixed amount of token at once. But real world documents are often thousands or millions of token long. So that is why we break it down into smaller documents. Okay. How do we break it down into smaller documents? There can be different strategies. Sentence level chunking, page. So we take a document and then what do we do? Sentence by sentence, we break it into smaller parts and then embed it or convert it into a vector. We can chunk it at a page level. So if a document has 100 pages, I take each page and then chunk it, right? Or break it page by page, then embed it and then store it in the database. Hierarchical chunking, which means that I want to retain the information, that if I have a document where I have a header, subheader, and then so forth and all, like I have various sections and I want to retain that information as well, right? So that is where hierarchical chunking comes in. Semantic chunking, which means that I will, whenever I chunk the document, I will do it in such a way that documents which have similar meaning, right, they stay together. And custom chunking is like I take a number that I will break the document, like after every 500 characters, I'll chunk or break the document and store it in the database. Okay. So we will look into each of these chunking strategies. And this is like very important. Okay. We will, in the next class, we'll go into like why this is important. Because when we are doing a vector or a similarity search, right, what will happen is we need to, so if you have made bigger documents, like if you have not chunked the documents correctly, when it will try to do a similarity search, right? I told you in this part, right? It will take the user query and go in the vector database and try to do the similarity search, right? So if your documents are not chunked correctly, right, what will happen is during the similarity search, your application will suffer because context will get lost, right? Let's say if a user asks the question and the answer is in 2 pages, okay? So, and if you have broken down the pages at a page level, page 1 and page 2. So now what will happen is page 1 lives here, page 2 lives here. Your user query is embedded and it will go and match just this part, right? And it will not take the information from this page because you have broken it down in this particular fashion. So then it will become a problem for you. So that is why like I'm focusing on these chunking strategies as well, because they are very important when you build your application. So you have to use the right chunking strategy while you're building your RAG application, okay? So we'll go into like one more level of detail, like what does chunking actually means, right? Each of these chunking strategies, what do they actually mean? What does sentence level chunking means? Okay. So what it means is split text at sentence boundaries. Okay. So let's say, for example, this is one of our docs where we have the return policy. So that doc contains something like this. Our return policy is 30 days. Items must be unused and refunds take 5 to 7 business days, right? So this is the whole paragraph. So when I'm doing the RAG process of, when I'm doing the process of chunking this phase, the indexing of the documents, what I will do is if I'm doing a sentence level chunking, I will create chunk 1 with the first sentence, chunk 2, this sentence, chunk 3, this sentence. Okay. So this is sentence level chunking. Page level chunking, like I already explained, I will take chunk 1, all the text from page 1, chunk 2, all the text from page 2. Okay. If I have to do, so this is page level chunking, and then store this in the vector database. If I have to do hierarchical chunking, what I will do is I have my document in such a way that sections are related. I am describing a topic section wise. So with hierarchical chunking, I will chunk the documents in such a way that I know that my chunk, which is at 3.2, knows that I am a part of this particular heading, right? Like let's say leave policy, right? Like vacation is a part of leave policy, right? So when I'm chunking vacation, I know that I am a part of the leave policy. This will also come in handy. How we will look into this, but right now you can understand that hierarchical chunking is where we know that okay, at the top document, the bottom document knows that I belong to this section. Okay, so that relevant sections are chunked together. We'll take one more example to understand this better. But high level, the idea is this. Semantic chunking, what it means is, we'll take an example. So again, the same thing. Our return. So let's say we have this particular document which says our return policy is 30 days. Items must be in original packaging. Refunds are processed within a week, right? And then there is another paragraph along with it, right? We also offer a loyalty program, earn 1 point per dollar spent, right? So these two were together. So when I do the chunking, right, I'll try to figure out the semantic meaning. I will take this particular sentence and I see that, okay, these sentences have almost similar meaning. So I will create one chunk out of it. I see this is like unrelated. So what I will do is I'll create a separate chunk, which is like maybe this is the nth chunk. So this will become the n plus 1th chunk, right? So based on the semantic meaning of the sentences, I'm chunking the data. So this was semantic chunking. And then, like I said, fixed size or custom chunking is like you decide that, okay, I will chunk based on 200 tokens. So you take the documents, first 200 characters, chunk one. Next 200 to 400, chunk two. Next, like 400 to 350, chunk three. Like this, we do it. Okay. So these are the various chunking strategies which comes from this part. I have my company docs. I am splitting them. I told you different strategies of how do we chunk the data or how do we store the data. Now let's come to the part wherein like how do we store the data? Okay, how do we convert the data, these chunks? So we saw we have those big documents, we chunk them into small documents. Now we want to convert them into smaller vectors, right? So we took a very good example during our when we were learning LLMs, right? The internal working of the LLMs, the vectorization process came in. So over there we saw this part, right? So if I have Apple, if it is represented as this number, right? 0.5, 10.9, 0.7, this is a vector of the word apple. So we saw that example, right? How does this vector how is this vector formed, right? We saw that if living, edible, size, and dangerous is an axis, we try to encode the meaning of the apple along these axes. I had taken a very good example and showed you that what this particular vector means. So same thing will happen now. After I have documents, I have created chunks. I will convert each of them, each of those sentences into these vectors. Okay. So these vectors will, the sentences will be converted into vectors like this. Like this is similar to our previous. And from that lesson, we should know that how is the meaning encoded, right? Within these numbers, we can see how the meaning is encoded. We had explained, we had seen this in the detail. Go back once to the notes and revise like how do these numbers encode the meaning of the sentence. Okay. So after this, what will happen is we will store these vectors into the vector database. Okay. So we also saw this part, right? Once we have done the vectorizations, the vectors which are like, let's say your leave policy of temporary employees and leave policy for permanent employees, right? So in the vector space, they will be close to each other. Payments in India, payments of USA, payments of Canada will be close to each other. Like resume of Ankit, resume of Manoj, right? These documents which are similar live close or close to each other in the vector data, in the vector space, and also in the vector database. Okay. So now till now this is clear, right? We are still in this phase. Okay, let me reiterate. We are still in this phase, which is the indexing phase. We are taking the documents, we are chunking them, we convert them into vectors, and then store it into the vector database. So we saw what is the data source, what are the different text and chunking strategies, and how do we convert it into basically embedding models, and then storing it into the vector database. Okay. So this was still the embedding models. Now for every sentence, we will get like vectors like this, the numbers. Now we will take these vectors, the embeddings for the documents, and store them into the vector database. Okay. Why do we need vector database? Traditional databases do not support storing vector data, right? SQL stores the data in the form of rows and columns, right? But here, if we see, right, we have transformed our data into this vector format, right? So obviously we cannot use traditional databases over there. So that is why vector databases is a specific type of a database which came in after like AI become very famous, or these RAG applications became famous, because then traditional databases could not be used for this. Storing these vectors is the first point. And traditional databases also do not do similarity search. Like I said, right? What they can do is they can do keyword search. So there is a difference, like I explained, right? Keyword search is matching word to another word in the document and retrieving that. Similarity or semantic search, meaning that sentence one is there, what is the semantic meaning or what is the intent of this sentence? Sentence two is there, maybe the words are different, but is the meaning or is the question the same? So finding out the intent and then doing a match on that. So traditional databases cannot do it. So that is why vector databases were required. Okay, 2 points for that. For storing the vectors, they are specific representations. So normal databases cannot support that. Second thing is doing similarity search is not supported in vector databases. So that is why in normal databases, that is why we need vector databases. Okay. So now how similarity search is done? It is done using cosine similarity dot product. We have seen that seen this part, right? That what will happen is if I have two words like dog and cat, right? So what we do is they will, if I measure them, if they have their own vectors, right? So like we saw, right, we can measure the angle between them. That is cosine similarity. That do they belong to the animal category or not, right? So that is what cosine similarity is, like how similar certain things are with respect to each other. That is measured via cosine similarity or dot product or Euclidean distance, right? We just need to understand this on a high level, that how similarity search happens. These terms should be familiar to you. We have discussed cosine similarity and dot product in details. So you can go back and look at those classes once more. But this is how vector databases do a search, a similarity search, right? Now, what are some common vector databases present in the market, right? So there is Pinecone, Viviet, Quadrant, Milvus, or ChromaDB. Okay, so these are some of, like, we have MySQL, Postgres, and all, right? So these are the companies which provide vector databases. Okay, now the existing databases provider also, they also expanded their capabilities. Like Postgre we use, right? So it provided one extension called PG Vectors, which can act as a vector database. Okay, MongoDB is there. It created an extension for itself, which is called Atlas Vector Search. That is what you can use to store vector data. And these are the options which we will use in production. There are other options, like if you are building a POC or something for your companies, then you can use in-memory vector databases. We'll use this in the next class. This FAISS, this is an in-memory vector database. ChromaDB, this is an in-memory vector database, which means that we don't need the whole database application. They can store the vectors in memory. Okay, so we'll see this in place. So these are the vector databases present out in the market today. Why do we need a vector database? Because vectors are traditionally different data from our traditional data. So we need a special database to store it. And they also can do similarity search. So that is why we need vector database. So overall, this layer is now clear what we will do, right? I am building a chat application which can answer company specific data. So I will first take the data, break down the data, convert the data into vector, and then store it in vector DB. Okay. So this part is clear till now. This is what will happen. Now let's take one example to show you how does it matter end to end. Like I said, right? What is the indexing layer? So first, I am building a chatbot application, right? To answer my company specific data. I will take the documents, chunk them, embed them, store them in the DB. How will it be stored or embedded? How does the embedded documents stored in DB is like this sentence: return policy in 30 days will something look like this in the vector for this will look something like this. Similarly, we ship to 40 countries, we'll have a vector something like this, right? So these, we took the document, we chunked them, we converted into vectors and stored them into the vector databases. Okay. Now see what will happen. Now I have built a chat application and the user will type its question. It will go to the LLM. Okay. Now LLM will figure out, hey, I don't know this answer to this question because I was not trained on this company specific data. So let's say I am using OpenAI or ChatGPT or any of the GPT models. Okay. So they will say, hey, I don't know your company specific data. How can I answer that? Right? I don't have that information. Now, after knowing that, what we will do is what it will see is it has one tool which can it will see, okay, let me look up the one database which is provided to me. Does that have that answer? So what then it will do is, whatever the user question which was passed, it will take that user query and convert that user query also into an embedding, right? Embedding what it is, just the vector of that query, right? The user query was like, let's say, what is your return policy? So it will convert that into a vector. Now it will go to the vector store and do a similarity search over here. After doing the similarity search, it will figure out which documents match this particular user query. And from that, it will return the top 20 documents or top 10 documents that is configurable. So basically, it will make an API call to the vector database, get the data, and then what it will do is format the response. It will figure out what is the most relevant answer based on the user query plus whatever I got from the vector database, and it will give the answer. So what happens now, you saw, right? We have created this framework over here wherein LLM initially did not know the answer, but it saw that, hey, I have a tool call, I have access to a database. Let me look up if that database has the answer. It looked up that, figured it out relevant documents, and then gave back the answer. So the advantage which we got is Previously, if this workflow was not there, in order to answer that question, that the model had to be trained on that on all of this data, right? Now, the advantage that we are getting is we don't have to no more train the LLM if our data is keeps on changing every 1 month or so. What we will do is, if the data is changing, I will just change this top workflow, which is the indexing workflow, wherein I will keep on indexing new documents into the database, and automatically when user queries come in, they can find this information from the vector database rather than fine tuning the model every time. Okay. Is this clear? Is it making sense? Like, what are we doing in the RAG part? Wherein instead of fine tuning the model every time, what we are doing is we are using a strategy wherein we are chunking and storing the documents, whatever gets updated from time to time into a vector database. And when the user query comes in, LLM decides that, hey, I don't have the answer to this question. So let me look up but I have been provided a API call which can look up database. So let me figure out if that has the answer. It will go to the vector database, see if it returns any document. If it returns any document, then chatbot, like we train chatbot to answer in the Q&A format, right? So I got top 10 documents. Which of them are relevant? Let me format the responses accordingly and answer back to the user. So in your companies, if you're like how companies are adopting to AI is, first and foremost, they will, like you might have seen support agents, right? They create support bots and all these things where they are using this RAG workflow, wherein like based on your company documentation, they can answer the data. No more why humans are being removed, right? A human would go in, like let's say if you are the support agent previously without the AI workflow, right? What would have happened is, like you are the support agent. Now let's say if a user asks a question, you don't know about that question yet, right? What you will do is you will go in, look up the support docs, try to understand that, and then after some time give the answer back to the user, right? Now that human itself is not needed, because what we have done is we have taken the company documents, stored it in the database, and we have built a pipeline wherein continuously this thing will be happening. And whenever a user question comes in, the bot has become an AI bot where it can look up the answer on its own and answer the user, right? So that is where we have automated the process where we don't need a human to go in and look up particular documents and answer. The AI bot can itself do it. Okay. So this is an example of an end-to-end flow, like how RAG works. This is again the same thing, but I hope this whole workflow, is it clear? Any questions?